right, so today we're going to look at a different kind of graph and what I would label as 1 over graphs. The one's over, I guess, I don't know. But we're going to start by looking at an equation that you do know how to deal with, which is y equals x squared minus 1. And let's start with that. And of course, that's pretty basic. We would start with, okay, the y-intercept is -1. The x-intercept is when we factor, and hopefully it's pretty easy for you to see that it easily factors into x plus 1 and x minus 1. For thinking about this chapter, we could have also pictured it like this. We could have said, hey, wait a minute, couldn't I move the 1 over, and so that's y plus 1 equals x squared. And so just the same, it's the x squared graph moved down, right, 1 unit. And so there's your x squared. It's pretty obvious. And so coupled with what we already know, we can see the intercepts as -1 and 1. That's what this parabola looks like. Now, when we see 1 over x squared minus 1, it changes things because, as you know, you cannot divide by 0. And so at this point, when you see that this denominator equals 0, a problem occurs. It becomes undefined. So we have to address that, and it certainly changes the graph substantially. What's going to happen, and I don't mean to overgeneralize, but I will to some degree on this unit and in this particular part of the unit. But as we move forward in this course, you're going to find out we'll do limits, and there we'll be able to examine these more closely as to why they do what they do. So truth is, this is just an introductory lesson as to how they look, but know that we'll get to the root of why they look this way when we get into more knowledge about limits, which is something you're not familiar with. So again, these spots of where this denominator is going to equal 0 are points that we have to make mention of. And in fact, they're undefined or holes within the graph. And so the way that this takes on is we already know that this x squared minus 1 equals 0 just by looking up here at -1 or 1. Or you can see it from your graph up here that those are the two x-intercept spots. At those intercepts, we now have what we call an asymptote. And so it's at -1 and it's at +1 that we now have the asymptote. What's more is you need to somehow picture this in your mind, that as these numbers are getting bigger, as these arrows are going up and up and up, what is happening when you do that with a fraction is the values actually are getting smaller. Let me explain. If we start by looking at, we'll start with 1 over 1. We all gather that that's 1, and that's easy. As that number in the denominator increases, we see that what actually is happening to the value, the overall value of that fraction, is it's getting incredibly small. So picture this with me. If you look at the original graph again, where it's closest to 0, like 1/2, so 1 over 1/2, or 1 over 1/3, or 1 over 1/100th, it actually becomes a regular number or a big number. So the closer to that intercept, it actually is going higher. But the further away, and as this continues to go up, it gets incredibly small and closer to 0. And the same holds true, not just on the negative side, but also on the positive side. It will do the same thing. Then, in the middle, what you're going to see is it also is going to do the same kinds of things. As these numbers are getting closer and closer to that 0, it's going to actually get larger and larger, and that would happen on both sides. Now, the only thing that we need to point out here is that 1 over 1 is still 1. So 1 over -1 would still, so that still actually happens there. What happens to these parabolas is the ends flip out, and the middle of that parabola will actually invert, or will flip also. Let's do another one. Again, it does help to think about what the original graph looks like. So before I do 1 over x squared plus 4x minus 5, I'm going to look at the original graph. Since we're in this translations chapter, I think it's really helpful if we kind of focus on that translation method and we do the completing the square. So that's x plus 2 squared. And we have, of course, the minus 5 here. But we would have a positive 4. So I'm going to subtract 4. So what I have is y plus 9 equals x plus 2 squared. If you need to, take a moment, think about that and how I got that. But what that basically is saying is that I'm taking my x squared graph, I'm moving it to the left 2, and I'm moving it down 9. And that would be my turning point. And as we've talked about before, you go over 1 and up 1, that would give you your next value. Over 1 and up 3, over 1 and up 5, that's how the pattern of parabolas go. And so this is what I have. It does help to know what these intercepts are. And of course, this crosses at 1 and this crosses at negative 5. With that knowledge, now let's look at what this graph, the 1 over x squared plus 4x minus 5. The first thing that helps to know is that you know at negative 5 you have an asymptote, and at positive 1 you're going to have an asymptote. Those are the spots that are going to make that denominator equal to 0. If I was to put 1 in the bottom, I'm going to get 0. If I put negative 5 in the bottom, I'm going to get 0. And so that makes it undefined. Now, again, trying not to overgeneralize, but what happens here is the ends flip out. So the part that's closest to that negative 5 is going to now be up very high, and then as I move away and it continues to go up on that graph, it actually will move towards 0, and the same holds true for the right-hand side. Now, in the middle here, I want you to think about this. Instead of it crossing at negative 8 now, it's 1 over negative 8. That's your intercept. And instead of your turning point being at negative 2, negative 9, it's going to be at negative 2, negative 1/9. It gets closer to here. It really just completely alters that graph. So this would be negative 1/8. And that's what I am looking for. Your turning point would be negative 2, negative 1/9. And that's how that looks. Now let's do some more of these. All right, x squared minus 9, again, just to understand what that graph looks like, that's y plus 9 equals x squared. That means we're taking our x squared graph, we're shifting it down 9. If you could think about what those intercepts are, hopefully it makes sense to you. So as I do the next graph, as I do the 1 over x squared minus 9, again, what are the two spots where those asymptotes are going to fall? Negative 3, positive 3. Again, what happens is those ends are going to flip out. And instead of this being at 0, negative 9, it's going to be at 0, negative 1/9. And then I just draw that parabola upside down. Let's try another one. 1 over x squared minus 8x plus 15. So once again, x squared minus 8x plus 15. Just to do it old school way, because I know some of you are more comfortable with that. That would mean you'd have x minus 5 and x minus 3 equals 0. So that gives you at 3 and at 5 is where your spots would be, right? And your turning point would occur at 4. And plug in 4, you'd have 16 minus 32 plus 15, so that's negative 1. Sorry, it's not really drawn to scale now, is it? It would cross here at 15. And so as I do the 1 over graph, that means now that at 3 and at 5, we have the asymptotes, right? And those wings are going to flip out. And in this spot here, instead of being at 4, negative 1, well, it's still 4, negative 1. Why is it, again, that that stays the same? Why didn't it change to a fraction? Hopefully, in your mind, you're thinking about 1 divided by 1 is still 1. And so it didn't change that value. But it does invert the rest of these to become larger numbers. And so larger negative numbers, that is. So that's what you have there. And those are the examples that I would like you to have in your notes for tomorrow. And this is how to graph 1 over f of x.